Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be evaluating the tangent of a complex number. Now you probably know tangent from trigonometry, hopefully, and we can, let's say, given a real angle like pi over 3, pi over 6, pi over 4, we can easily calculate the tangent by drawing a right triangle or looking at the unit circle, right? Or maybe you even memorize them. But how do you tangent a complex number? What is a complex number? A complex number can be written as a plus bi, where a and b are real numbers and I is the square root of -1. All of these and other stuff I go over in my lecture videos, so if you're new to complex numbers, go ahead and check them out. And let's go ahead and see how we can evaluate the tangent of 1 plus I. So, to be able to do that, we're going to consider a formula for tangent theta when the theta is complex. And there are some formulas, but we're going to start with the following. Tangent theta, first of all, can be written as sine theta over cosine theta. So this is true even when theta is not real, it works. So do we have a formula for sine and cosine? Yes. So for example, cosine theta can be written as e to the I theta plus e to the negative I theta divided by 2. And sine theta can be written as e to the I theta minus e to the negative I theta divided by 2i. But where do they come from? Let's quickly talk about those. I don't want to go over the whole thing. But if you think about Euler's formula and consider e to the I theta can be written as cosine theta plus I sine theta. And of course, if you replace theta with negative theta, then you get cosine theta minus I sine theta because cosine is even and sine is odd. And then by solving the system for sine and cosine, you get the following identities. Cool. Now, that's where they come from. Let's go ahead and use it. But we do need tangent, so we're going to need to divide sine by cosine. So let's do it. Tangent theta, instead of memorizing a formula for tangent separately, right? Sine theta will be divided, so we're going to write the sine first. And then division means multiply by the reciprocal, which is 2 over e to the I theta plus e to the negative I theta. Awesome. Now the 2's cancel out. That's the only simplification we can make so far. So let's go ahead and cancel them out. But we can also do something like this. We can multiply top and the bottom by e to the I theta but before we do that, let's multiply by negative I. And a lot of times people are just going to multiply by I, but I like the negative I better because negative I squared is 1. Did I tell you that? I is the square root of -1, so I squared is -1. Therefore, negative I squared is +1. Get the idea? So now we don't have anything here. And now we can go ahead and write this as negative I multiplied by e to the I theta minus e to the negative I theta. And that is divided by e to the I theta plus e to the negative I theta. Great. Now that's tangent theta. So we kind of have a formula. If you want to memorize it, be my guest. But I wouldn't. And then we can probably multiply by e to the 2I theta, or actually I theta would be good enough. Let's multiply the top and the bottom by e to the I theta and distribute it. This is going to give us a negative I times e to the 2I theta minus 1 because that's going to be e to the power 0. So we can kind of write it like this. And the denominator is just going to be same thing with the plus sign. Okay? So here's another formula for tangent theta. Guess what we want to do? We are trying to evaluate tangent of 1 plus I, right? Okay, so we should replace theta with 1 plus I, and that should give us the answer, right? Well, it's not that simple. It's a little deeper than that, but let's go ahead and do the substitution. Tangent 1 plus I is going to equal negative I times. Now, in this case, theta is 1 plus I, so don't worry about replacing I with anything. E to the power 2I 1 plus I minus 1, and then the denominator. And this is also good. You know why? Because this eliminates all 4 substitutions. So instead of 4, we do it twice, which is good. So that's tangent 1 plus I, but you don't want to leave it like that. It's really like not simplified. So let's go ahead and distribute, or I don't think I need to write that every time. So negative I times this one, e to the power 2I plus 2I squared. I'm going to show my work, minus 1, and then e to the power 2I plus 2I squared plus 1. Now, remember I squared is -1, so we're going to go ahead and replace those with -1. So that's going to become like e to the power -2 plus negative I times e to the power -2 from I squared plus 2I minus 1 divided by e to the power negative 2 plus 2I plus 1. And we can still simplify this. How? By writing this as a product. So, and we could also distribute the I, but let's do that later. So now we can go ahead and actually write this as e to the power 2I divided by e squared minus 1. And then this is going to be e to the power 2I divided by e squared and then plus 1. Now we can multiply top and bottom by e squared if we want to get rid of all the fractions, right? And then this will give us negative I times e to the power 2I minus e squared. And then this will be e to the power 2I times, plus e squared. Okay, here we go. So that should be the answer, but we can simplify even more than that. How? Let's go ahead and replace e to the 2I with what it is. What is e to the power 2I? What does that mean? How do you raise a transcendental number to an imaginary power? So like imaginary, right? Okay, it's hard to imagine what that's going to look like. So again, Euler's formula comes to the rescue. E to the I theta is cosine theta plus I sine theta. So in the case of e to the 2I, your theta would be 2. Make sense? But be careful, it has to be in radians, so it's not 2 degrees, it is 2 radians. What happens if it's 2 degrees? Then you have to turn it into radians, but in this case, it's always in radians. So we're going to be looking at cosine 2 plus I sine 2. I'm not writing the degree symbol because it's in radians, okay? I keep saying it because sometimes I won't even write the degree symbol with degrees, but they're going to be like 30, 45, bigger angles, like 2. It's a little different. So what am I going to do with this? Substitute. So tangent 1 plus I one more time. It's going to be negative I times this, cosine 2 plus I sine 2. And then minus, plus I times e squared. Should I just distribute the whole thing? Yeah, I think I should do the whole thing. Wait, I should keep that in parentheses. Yep, and then I'll distribute. Minus e squared. And then in the denominator, we have cosine 2 plus I sine 2. E to the 2I plus e squared. Okay, great. Let's go ahead and distribute the I now. But here's one thing you need to remember. Now this becomes the real part. You got that? So we can kind of write this as negative I times cosine 2 minus e squared. And then when you distribute negative I squared, that's going to be a plus 1. So it's going to be plus sine 2. And then this will be negative. There's no distributive property. So we can write it as cosine 2 plus e squared plus I sine 2. Here, the real and imaginary parts need to be switched around. So we should write it as sine 2 minus, you know what? I'll probably do it this way, like this. And so that I can put a plus I there. It doesn't matter, same idea. And then here, we're going to have cosine 2 plus e squared plus I sine 2. So now, this is the real part for the numerator. This is the real part for the denominator. And those are the imaginary parts. You get the idea? And you can replace cosine 2 with what it is, e squared with what it is, multiply by the conjugate, just turn it into a complex number like a plus bi. At the same time, it's the name of this channel, right? I also have another channel where I focus on algebra, number theory, and trigonometric problems. That's called CyberMath. Maybe you already know, maybe you don't, but I'm letting you know now. So go ahead and check it out as well. So let's go ahead and look at the results from Wolfram Alpha, because Wolfram Alpha can do the heavy lifting for us. And ta-da! The answer approximately is going to look like this. If this looks confusing, let's go ahead and take a look at this one. And this one is really, really weird, because where does the sine hyperbolic come from? The powers of e. E to the power I times x can be written as so on and so forth. Anyways, you can go ahead and look it up, because this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.